This is a example problem. Here let del G and delta G denotes, del G denotes minimum degree of all the vertices of an undirected graph, that is very very important, undirected graph G, and delta G represent the maximum number of degrees of in this graph. Okay, then so that del G less than or equal to 2 into number of edges of the graph divided by number of vertices of the graph less than or equal to delta of G. Okay. In some graph, take this graph V1, V2, V3, V4. What is the maximum number of vertices? Sorry, maximum number of degrees. V4 have the maximum number of degree. Degree of V4. What is the degree of V4? Degree of V4 is 3. What about others? Minimum degrees. Others? Minimum degrees. Degree of V1 1. Degree of V2, degree of V3. If you take any undirected graph, we can find maximum number of degrees, maximum number of degrees and minimum number of degrees vertices. Here we have to take maximum number of degrees vertices such as delta G and minimum number of degrees as del G. First we have solution. Let del G is a maximum, that is minimum degree of G. Here G is undirected graph, not mentioned this is a simple graph or something else. Simply they said that it is undirected graph. Let del G is a minimum degree of G. So degree of V is greater than, or del of V should be less than or equal to degree of V for all V. This should be less than of any degree of the vertices. For example, V1, degree of V1 is 1, which is less than V4, or equal to V2, or equal to V3. That is called less than or equal to. Okay, degree of V1 is less than V4, equal to V2, equal to V3. So less than or equal to degree of for any vertex set. Okay. Next, likewise, let del of G is a maximum degree of all the vertices of G. Degree of the vertices, just write vertices of G. Degree of vertices of G. Okay, so this satisfies which condition? This is less than or equal to condition. Okay, this is less than or equal to condition. That will satisfy which condition? Delta of G greater than or equal to degree of V for all vertices sets. Okay, listen. V4 is greater than degree of V1. Degree of V4 is greater than degree of V1. V2. degree of V3, okay, and equal to V4. So greater than or equal to, and denoted number of edges E. E denote the number of edges. Number of edges. Next. N denotes, V denotes N, that is number of vertices. Number of vertices. Here also we are going to use handshaking theorem. Okay. Combined 1, take it as 1 and 2. Combine 1 and 2, or don't want to combine, let it be like this. Let it be like this. By handshaking theorem, finally we have to prove this one. Keep that in our minds. Okay. By handshaking theorem, 2E equal to summation I equal to 1 to n degree of Vi. Degree of Vi. Okay. Degree of Vi. So 2E equal to degree V1 plus degree V2 plus etc. plus degree Vn. Degree Vn. Listen. Apply the condition 1. Apply the condition 1. Degree of V. Del V less than or equal to degree of V. Apply this condition. Instead of degree of V1, we can write less than del V. We can apply less than del V. Like that we can apply all the value for all the terms. 2E less than or equal to del V plus del V plus etc. del V. How many times? How many times? Actually degree of V1 not equal to delta V, but less than or equal to del V. Less than or equal to del V. So used less than or equal to symbol here. Now we can apply this value. How many times? N times. N times. Why it is n times? Because 1, 2 up to n. So n times. Next. 2E less than or equal to, instead of this we can write n into delta V, because already I explained 2 plus 2 plus 2 can be written as 3 into 2, because 3 times 2. How many times? N times. N times del V. N times del V. Bring this n denominator. 2E divided by n less than or equal to del V. Take it as 1, 2, 3. Take it as 3. Like that we have to apply handshaking theorem for delta, that is maximum degree of all the vertices. The symbol only will change, greater than or equal to. Okay, greater than or equal to. Just copy down. Just listen. Apply the star. Here we used delta V. Again we have to use 2. So from star use the 2. Use or apply 2 in star. Apply 2 in star. So 2E will begin. Listen, here we have to use which one? Greater than or equal to. So degree of V1 we can use greater than or equal to del G. In each and every term we have to use del g. So this symbol will change. Equal to will become greater than or equal to. So greater than or equal to del g plus etc. del g up to n times. So 2e greater than or equal to n times del g. N times del g. Bring n denominator. 2e divided by n greater than or equal to del g. Take it as 4. Take it as 4. From 3 and 4. From 3 and 4, we can come to the conclusion delta g less than or equal to 2e divided by n less than or equal to del g. What is e? Number of edges. What is n? Number of vertices. Delta g less than or equal to 2e divided by v less than or equal to del g. Okay, right, problem. Stop here.